Welcome, I'm Dr. Noshu. This is our introductory lecture to the course of Data Science for Business. If I have to use one word to describe what this course is about, it will be about prediction. So I will open up with explaining how is it possible to predict the future. We'll then describe three distinct groups of business problems and explain how data science can provide solution to these problems. Along the way, we'll touch on quite a number of concepts and terminologies that are integral to data science. We'll get back to them with certain depth over the course of this semester. We'll conclude this introduction by giving a definition to data science. How is it possible to predict the future? I'll use the credit scoring as an example to explain how that is possible. So if you apply for a credit card, the car issuer needs to make a prediction on whether or not you will pay them back in time. The tool they use for such prediction into the future is the credit score, such as FICO score. I'm going to describe to you how credit score predicts defaulting behavior, i.e., someone failing to pay one's debt on time. I will first give you a highly simplified and compacted answer with a few statements. I will then follow up with more details to substantiate these statements. The short answer is, by examining data, we observe patterns that link yesterday with today. We assume those patterns persist over time. We extract and store those patterns as models. For now, you just need to think of model as a black box. With inputs, it produces outputs. We then feed these models with today's information as inputs, and the models predict tomorrow as outputs, according to the stored patterns in the models. Let's now look at more details to make sense of this short answer, starting, of course, from dataset. We go to credit bureaus such as TransUnion or Equifax. If you have not heard of credit bureaus before, please pause and do a 1-minute read on its Wikipedia page before proceeding with this lecture. We retrieve financial records for, say, 100 people over the last 10 years. We summarized the financial records into a table like the one we are seeing here. So every row represents a person that we call an instance. Every column represents a piece of information about that person. Let's now look at how each column is defined, starting with the last column that we call target variable. So out of the last 10 years of financial records, we call the last 2 years, which is today to 2 years ago, as the performance windows. We look at each of those 100 people and see whether they have defaulted on any of their debt obligation, such as credit card, car loan, mortgage, and student loans. As long as one of the debts was not paid, we will mark this person as bad account. Otherwise, we'll mark them as a good account. Essentially, we are creating a binary variable that we call the target variable that has only two values. It's either good or bad. It's important to remember that the target variable is defined only using information in the performance window, i.e., the last 2 years. We then look at financial records from year 2 to year 10. which is referred to as the observation windows. We compile a bunch of information on each individual within the observation windows. For example, monthly incomes, number of cards that one person has in the observation windows, monthly balance on each card, credit line on each card, so on and so forth. We call each of these piece of information an attribute. And oftentimes, demographic information will also be collected and transformed into a number of attributes. Now remember, attributes are based only on information in the observation window. I think now you can guess the purpose of this temporal setup of observation window versus a performance window. We hope there are patterns existing between attributes, which are defined in the observation windows, and the target variables, which is defined based on the performance windows, that would allow us to make prediction at a time point of 2 years ago about what happened in the last 2 years. A hypothetical pattern emerging from data could look like this. If a person's monthly income is greater than his or her balance by $1,000 in the observation window, then he or she is always going to be a good account in the performance window. If a person's monthly income is about equal to his or her balance, then he or she has 50% chance of becoming good or bad. If a person's monthly income is less than his or her balance by $1,000, then he or she is always going to be a bad account in the performance window. We can then use this kind of pattern for prediction. Let's now recap the whole process using the following diagram. You store this kind of patterns in a model between attributes and target variable. The attributes are defined based on the information available between year -10 to year -2. The target variables is defined based on the information in a time window between year -2 to now. You then apply this model using attribute defined based on the information of the time window between year -8 and now, and the output of the model is the target variable for the future, which is now and 2 years from now. So here you have it. This is the essence and flow of how we predict the future in data science. There are many business tasks that can be cast into the exact same problems as credit scoring. Here we are lumping them into business problems group 1. Again, the credit scoring problem. How to determine whether or not a loan applicant will repay what they owe on time. From the field of telemarketing or online advertisement, how to determine whether or not a prospective customer will respond to your marketing offer. In recruiting, how to find candidates out of hundreds of applicants that will succeed in a particular job. Now, pause the video and spend a few minutes recalling business problems that you have encountered that also share the same structure. What these problems share in common is we are trying to predict the future behaviors of an individual, or using data science term, an instance. Collectively, we call this type of modeling effort predictive modeling. The outcome of the prediction could be a class or a label. For example, it's either going to be good or bad in the credit scoring example. It's going to be either respond or not responding in the telemarketing example. It's going to be a success or a failure in the recruiting example. We call this type of prediction classification. There's a slightly different flavor of prediction. The outcome of prediction, instead of a label or a class, is the probability of belonging to a class. For example, in the credit scoring example, we might be interested to predict what is the probability for someone to become a good account or a bad account in the next 2 years. And since it's a binary variable, so if the chance of being good is 10%, in the next 2 years, that means the chance of being bad would be 1 minus p, 90%. Similarly, we might be interested to predict what is the likelihood that someone will respond or not respond to a particular offer, or predicting whether a candidate, what is the likelihood for a candidate to succeed or fail on a particular job. And we call this type of prediction class probability estimation. In the upcoming weeks, we'll spend more time discussing how to actually build a predictive model, and more importantly, how to use them in improving decision making in business. Specifically, we'll be talking about 3 aspects of predictive modeling. The first one is how to tell whether an attribute can predict the target variable. Let's see if we can glean some insight from a little bit of drawing on the credit score example that we studied earlier. Let's say out of the 100 people we collected, there are 50 bads, which are denoted as 1, and there are 50 goods, which are denoted as 0. And we have 2 attributes on each person: the last 4 digits of social and the monthly income. I'm going to plot the target variable. In this case, is either going to be 0 or 1 against the social security numbers and monthly income in 2 separate scatter plots. Looks like these here. Let me show you what I meant by plotting these first 2 persons in these 2 graphs. Person number 1, the target variable is 0. The social security number is 1, 2, 3, 4. Therefore, that person on the first scatter plot should fall somewhere here. The same person in the second scatter plot, again with the same target variable as 0, therefore it should be on the horizontal line. And the monthly income is 3,600, so he or she should be somewhere here. Let's look at the second person. The target variable is 1, therefore it should be somewhere in this horizontal line at the value of 1. And again, the social security is 5, 6, 7, 8, therefore he or she should be somewhere here. And for the monthly income, it's 2,500. Again, the target variable is 1, therefore he or she should be somewhere here. Now, I want you to pause the video and get out a piece of paper to complete these 2 scatter plots. And since we only have 2 persons here, you need to use your imagination and make reasonable assumptions to fill the rest. You don't need to draw things to scale. is just for the illustration purpose. Ask yourself whether Social Security should predict the target variable. We already know monthly income is predictive because it's in the hypothetical patterns we described earlier. So how should these two graphs look differently? Share your results in the discussion board. I just added the coordinates next to each of the 4 points. So hopefully it's clear enough for you to attempt your drawing. Remember, there are 50 goods and 50 bads. If you draw them correctly, you should see two very distinctive patterns emerging. In the module titled Predictive Modeling Part 1, we will be talking about how to quantify these differences with entropy and information gain, and how these two can be used to select most predictive attributes, the so-called attribute selection problem. In decision science, attribute and feature are synonymous to each other. The second aspect of predictive modeling we will discuss is how to combine multiple predictive attributes for prediction. The answer to this question is to use models, or the black boxes that we were referring to earlier. We'll spend some time to peek into those black boxes to understand how they work from inside. We will mainly talk about two types of models. The first type is called rule-based models. For example, decision trees, which we will cover at the end of Predictive Modeling Part 1. And the second type is called mathematical function-based models. For example, logistic regression or neural networks, which is a topic we will cover in the module Predictive Modeling Part 2. A number of key topics that we'll also cover in these two modules are recursive partitioning, parametric modeling, objective functions, and optimization. The third aspect of predictive modeling that we'll address is how can I trust prediction from a model? How should I use a model for decision making? These are the questions that we are going to answer in the module Predictive Modeling Part 3. A number of key topics that we will be discussing in this module are performance evaluation, profit curve and ROC curve, and expected value based decisioning. Before we read our business problem group 1 and its decision science solution predictive modeling, I want to quickly mention there's a variant to business problem group 1, such as in credit scoring, we might be interested to predict how much do people spend on their credit cards. In the marketing example, we might be interested to predict, given someone has responded to an offer, how much will that person buy that certain product. And in recruiting example, we might be interested to predict what is the proper salary for a particular job description. So in these cases, the target variable is a numeric number instead of a class or a label that we had discussed so far. We call this type of predictive modeling regression. Regression is a topic typically covered in a statistics course, therefore we'll not spend much time on it in this course. Now I want to introduce to you two new terms that are very important in decision science. They are important because they provide a structure through which we can better compare business problem group 1 that we have discussed and business problem group 2 and 3 we are about to discuss. Predictive modeling is also known as supervised learning because there's a target variable to supervise the pattern learning process. So far we have covered classification, class probability estimation, and regression. These three are the three examples of supervised learning because they all have a target variable. There are models in data science where there is not a target variable to supervise the pattern learning process. We call those models unsupervised learning. We'll next turn to the discussion of unsupervised learning and see how it can provide solutions to business problems Group 2 and Group 3. Business problem Group 2. In customer retention, we want to redesign our current pricing structure on our cell phone product to meet different needs of our existing customer base. What distinct usage behaviors can we identify? From HR management, we want to develop a limited number of training programs, each tailored to a particular group of our existing employees who share the same needs. Investment. We want to reevaluate the small cap companies in our portfolio to further differentiate unique company DNAs among them. Now pause the video and spend a few minutes thinking of business problems that you consider as an example of business problem Group 2. We will provide a solution to Group 2 problem in the module of clustering analysis. The key notion of clustering analysis is the concept of similarity. Let's now look at an example. Here we have a data set of monthly cell phone usage. Each person is described by two attributes. Attribute 1 is the number of texts sent per month. Attribute 2 is the number of minutes talked per month. In terms of usage behavior, do you think Jane is more similar to John or to Linda? The answer is not obvious. So I want you to pause the video again and get out a piece of paper to draw another scatter plot like this one. In the horizontal axis, you represent number of texts sent. And the vertical axis, you represent number of minutes talked. So I can describe Jan as a point in this, again, two-dimensional scatter plot. Say if this is 100, 300, minutes here, say 900, then Jan would be a point somewhere here. So I want you to complete the scatter plot to represent all three persons. You might need to adjust the scale on each axis. And to answer the following two questions: which two of the three persons are more similar to each other? And what is the measure of similarity you used? Share your discovery at the discussion board. So the goal of clustering analysis is to group instances into groups so that they are similar within a group and dissimilar between groups. We will use two methods to conduct clustering analysis. The first one is called K-means. The second one is called hierarchical clustering. Let's now move on to business problems Group 3. Recommendation. Netflix recommends shows to subscribers that it think they will like. Store design. Putting two items that people tend to need together close to each other, such as shampoo and body wash, so it's convenient for the shoppers. Again, store design. Putting two items that people tend to need together far apart from each other, so that they have to spend more time walking, hence buying more stuff on the way. Now again, pause the video and spend a few minutes thinking of business problems that you would consider as an example of business problem group 3. We will provide solution to group 3 business problem in the module association rule minings. The key notion in association rule mining is the concept of co-occurrence patterns. Let's again look at an example. Here we have a transactional data set from a grocery store. So each instance represents a receipt from a shopper. One indicates an item is present in that receipt, and empty indicates that item is absent from that receipt. So in this case, receipt number 3 has all 3 items, milk, bread, and sugar, in that transaction. Notice if we change the attributes from milk, bread, and sugar to movie A, movie B, and movie C, and if we change the receipt number to subscriber numbers to Netflix, then this same data structure will be capable of capturing viewing behaviors of Netflix subscribers. Our goal here is to identify co-occurrence patterns and express them as rules, such as if milk is bought, then it's likely sugar will be bought too. We will introduce a method called a priori algorithm to automatically mining association rules from transactional data set in this module. Let's now compare and contrast the 3 groups of business problems in terms of their data structure. In predictive modeling, we are trying to find patterns that link the target variable with one or more than one attributes. It's supervised because we have this special column called target variable. In clustering analysis or association rule mining, we do not have this special column called target variable. In cluster analysis, we're trying to find patterns between instances. Or rows. In association rule minings, we're trying to find patterns between any 2 columns or any combination of columns. So hopefully this distinction could help you identify what business problems belongs to what groups. Let's now add two more notes to this taxonomy tree of data science for now. Clustering analysis, association rule mining, they both belong to the branch of unsupervised learning. Of course, this tree is constantly branching out and growing deeper in layers as data become more and more prevalent and abundant in all aspects of business. We have covered quite a bit of ground in the field of data science. The data we have discussed so far that can be represented as a table are called structured data. Unfortunately, the majority of data in terms of volume out there are unstructured data. They cannot be directly represented in these table structure. So we'll devote a separate module to discuss data science solution for these types of unstructured data. For example, we will talk about text mining, which deals with textual data. We also talk about web mining, which deals with linkage data, which captures the linkage structure between web pages, images, audio, videos, and user clickstream data that is unique to web pages. We also talk about reality mining, which deals with sensory data in real-time fashion, such as GPS data. So finally, we'll conclude this lecture with a definition of data science. Lots of time giving a definition is an act of catch-22. The definition of something only makes sense when you already know what that something is. But for the sake of completion, here is a definition of data science. It's the principles and techniques for extracting actionable information and knowledge from a large volume of data for improving decision making in business.